Okay, this lesson we're going to look at basic sine and cosine graphs. Here's the first one. We have a sine graph. So a sine graph starts at the 0 and we can see that it goes up and over and it cycles round. So if we think of our exact numbers, remember that at 0, sine is 0, so there we start there. And then at pi on 2, sine is 1, so we can see this point up here. Remember, if we keep going around the unit circle, at pi, sine is 0, and at 3 pi on 2, sine is -1, and then we're back to 0. So we've done a full cycle. So we can see that the graph goes up and then down and around. So this one cycle is called a period. So in a normal basic sine graph, it takes 2 pi time, before you to cycle once this pattern, to see this pattern. So if you were going to go, say you did like that, that would be up to 4 pi. Okay, so a basic sine graph. So this shape is going to keep going. So the amplitude is the highest value and the lowest value you get. So obviously we go up to 1 and -1 with the unit circle. So this is with the basic graph, the amplitude's 1, it's peaking up 1 and going down 1. Okay, so then if we look at a cosine graph down here in the blue, we can see that when we are at 0, cosine is actually 1, and then at pi and 2, we know it's 0. At pi, it's -1, and so on. So we can see this basic graph. So if you were to keep going and do whatever, so that would be, say, if you did 4 pi. So it does one cycle, or one period, it's 2 pi. This is a basic graph. So if we look at the next page, and we can see, now observe when we have 3. So 3 changes the amplitude. So if you can see, it's now peaking up on 3 and down on -3. So there's the 3. Now also the period has changed. The period is now cycling with pi. So the way you can calculate the period of a graph is you can use the formula, the period equals 2 pi divided by n, where n is the number in front of the angle. So see how this one was 2 pi divided by 2, so we ended up with pi. So now if we observe the cosine down here, we can see again, this 2, the number in front of the cosine, is telling me the amplitude. So you can see it peaks at 2 and drops to -2. So if we draw across there, we can see that. And this period, if you look and you follow the rule, so you can see they've done 2 pi divided by n, and there was the n there. So we found that it's going to do the one complete shape in 2 pi over 3 time. Okay, so just to summarize it up, the number in front of the sine or cosine is the amplitude, so A, and the period can be found by going to 2 pi over n. Okay, so now if you have negative, and so down here where we say we've got a negative in front, so what that does is it starts the graph. We normally go on a basic, we go up first. If we have negative, we go down first, and it would go like that. Okay, and the same with the cosine, so we see a reflection in the t-axis, so that would be t. So instead of starting up the top, it starts down the bottom and goes like so. So there's the reflection. Okay, so that's the negative. So if we have a look at this example here, we can see it's negative. So first of all, we are going to reflect it, so it'll go downwards first. We can also, you should also really work out the amplitude and the period first. So the amplitude is still 2, so it's going to go up and down to 2 because of that number there. And the period, we've done 2 pi divided by 1/2, because the number in front of the angle is actually 1/2 there. So we found that it takes 4 pi to actually complete one cycle. So you can see you go up, so half the cycle will be done by 2 pi and so on. Okay, so here's another one, a negative. We're just going to start down below. The amplitude is still 1 because there's a 1 there, and the period is going to be 2 pi divided by that 2, which is pi. So what I've done there is, so normally you should dot in, if you're sketching, dot in the amplitude so you know where you're going up and down to. Work out your period, so it's going to take me pi to complete one cycle. Now they want me to go up to 4 pi here. So I'm going to have to keep drawing all the way up to 4 pi, which is why I've got that there. Now what can help is to find the intervals, because we know when we draw, say, a basic cosine graph, that we have the quadrants of the unit circle. So there's the 4, so we start at 0 and then we're back to 2 pi. So it's sometimes good to find out these quarters, these intervals, and you can do that by getting the period and dividing by 4. So up here, if I looked up here and did the intervals for this top one, I do 4 pi divided by 4. So it means the intervals are at pi. So I'm going to see a dot every time at pi, and you do see, so there's pi and there's a dot, another pi, pi, pi. So down here, the intervals on this cosine is at pi and 4. So you might just pop them all in, all the little intervals. So you can see here is pi on 4, and then another pi on 4 would be pi on 2, and so on. And that can make it easier. Okay, when you have a vertical transformation, so that's just moving the graph up and down. So the value in front of that is still going to be the amplitude. That's still the A is still the amplitude, but the graph has going to be moved up or down. So if you have a look here at this one, the graph's moved up 1, but the amplitude is still square root 2. So you just move it up. So maybe if I draw a more basic one. So say if I said 3 cos x plus 4. Okay, so if I go to sketch that, we've got an amplitude of 3. So normally we'd go up to 3 and down to -3. But we're moving this whole graph up 4. So if you move this one up to 4, you're actually now on 1, and this one up 4 would become 7. So therefore, they're your new lines like that. You are still ampling up and that, and now because this one's period would be 2 pi over 1, so it's 2 pi. So you could just draw your graph, and so that would be, here would be 2 pi. Okay, so even up here in this example up the top here, we've got square root 2. So if we've moved it up, the top one is at this line here is square root 2 plus 1, and this bottom line here is negative square root plus 1. So, and you can work out roughly that'd still be in the negative. Okay, so your center line or your 0 line changes. So if you look here, it's y equals 0. In this one, the center line is y equals 4 because of this one here. Okay, so here's a couple more examples that you can look. So this is telling you the domain. So for how long to graph it for, telling you how long to graph it for. So you've got to go up to 2 pi. You can see I've calculated the period here, I've worked out the intervals, and I've popped it in. It has an amplitude of 2, but it's moved down 1. So you can see the 1 is like the 0 line. So if I go down, there's the 2, and there's the 2 there. Okay,